Welcome back to the Studio Shangri-La podcast. And what you're about to hear is a broadcast version of a recent article. This is Space plus Technology: Advanced Propulsion for Interstellar Travel. With a very promising 5,347 exoplanets and counting reported to NASA, the next question is, how do we get to them anytime soon? How do we expand humanity's evolution into deep space? Respect to Earth, of course. But our numbers are growing, and we're due to explore the vast cosmos. The answer is to develop more advanced spacecraft and means of propulsion or travel, which is key. Let's take a look at a few promising systems among many, both theoretical and already in use even. The first category is electric propulsion, specifically ion propulsion. And this is achieved by accelerating ions using electrostatic forces and solar panels as an accessory to create thrust. Accelerating ions to create thrust. A few NASA missions, including the Dawn mission to Vesta and Ceres, have successfully put this technology to use. The most recent NASA ion propulsion mission, though, is DART, or Double Asteroid Redirection Test. And that's another way of saying trying to move an asteroid out of the way. Hence the redirection part, or alter its trajectory. So in this case, NASA JPL, or Jet Propulsion Laboratory, cites IPS, Ionic Propulsion System, as being faster, cheaper, and safer. Faster, cheaper, and safer than chemical rockets, and further development of the technology continues to improve this performance. There are a lot of NASA references here, and rightly so, though it should be well acknowledged that more and more countries are participating in advancing space technology, and the playing field is becoming more inclusive and collaborative, and of course that is so much needed. Next up, the next type of propulsion is still very much in the experimental phase, and that is M-drive, or using electromagnetic waves to directly create thrust. That means there's no need for propellant. And although the mechanism of M-drive, or also known as resonant cavity thruster is not widely understood, it is nevertheless gradually starting to achieve results using electromagnetic waves to directly create thrust. And thus, M-Drive is pushing the science and technology into new physics. Although some sources describe this fuel-less M-Drive thruster as even mythical or impossible, nevertheless, NASA EagleWorks and the Limitless Space Institute were working on its development. Although, from what I could tell anyways, which is a limited vantage point, but from what I could tell, the development is seemingly at a halt. However, the use of electromagnetism is a strong concept that I think should not be abandoned. Perhaps the futuristic work of Nikola Tesla should be consulted here. That's the first thing that comes to mind when I think of the power of electromagnetism and electromagnetic technologies. So, further consulting that groundbreaking work and not completely explored work ought to be done if it isn't being done already. Nikola Tesla's very last patent was a spaceship that used, quote, anti-electromagnetic field drive, unquote. Anti-electromagnetic field drive. Something to further look into later. Okay, the next interstellar candidate is photonic or laser propulsion. Based on existing technologies, the high-level idea here is to fire a laser at a reflective surface, and the photons of the laser generate energy and momentum. This is currently supported by Breakthrough Starshot and the NASA Innovative Advanced Concepts Program. So many acronyms. And the Advanced Concepts Program is for probes and other types of spacecraft. Laser propulsion could theoretically, and I'm quoting a NASA article here, could theoretically beam a heavy spacecraft to outside the confines of our solar system in less than 5 years. A feat that took the historic Voyager 1 probe 35 years to achieve. That is incredible. To achieve travel outside of our solar system, interstellar travel, in less than 5 years. Okay. That's, of course, a very brief overview of photonic or laser propulsion. That's using a laser and particle beam transmitter to accelerate the craft. That brings us to the next section of the article. But before focusing on the last method of this article, here are a couple of honorable mentions, a couple of other propulsions under development. There's pulsed fission fusion, or PUF propulsion. And yeah, that's nuclear reference there. And antimatter propulsion. Okay, honorable mentions there, which means that there's, of course, a lot more to delve into in this topic. But here's the next section. The most theoretical and advanced method of this bunch, which is warp drive. Inspired, yes, by iconic science fiction. Though, often, science fiction becomes science fact. Because every technology that comes into being starts as an idea. Okay, the basic concept of warp drive is warping space-time. Contracting space in front of the craft and expanding space behind it using exotic matter and energy to create a bubble of sorts. There are several methods thus far, theoretical, once again, of achieving warp. The warp options, if you will, both superluminal and subluminal. Let's be honest here, the supposed superluminal or faster than light options are the most exciting because they would accelerate us into spectacular discovery faster, traveling farther faster. And what exotic matter and energy could break this cosmic speed limit, as it's called, faster than the speed of light? Possibly the theoretically faster than light tachyons or neutrinos, for example. Both are subatomic particles. Neutrinos, though, are known to be produced by a variety of nuclear processes and reactions. They are known to be produced. And as an aside, this relates also to the possibility of fusion drive. So neutrinos are known in nature. Tachyons, however, it's been said, contradict the known laws of physics. These laws, though, are based on human observation. An understanding of the universe and nature so far. There should always be room for the expansion of knowledge and the diversity of viewpoints. in order to expand beyond the known so-called laws and to see more, to be able to take in more information and observation. And that comes with a measure of humility and bowing down to the great mystery, so to speak. I'm not the first person to use those words, bowing down to the great mystery. I can't remember where I first heard that, but I like it. And why wouldn't we want tachyons to exist? Or something like tachyons, right? Instead of just saying, well, that can't be possible because it breaks the law. Why wouldn't we want tachyons to exist? Because tachyons are part of the quantum family of particles. And going into conjecture here and just positing possibilities, perhaps they could be a bridge between special relativity and quantum mechanics. Now, these two branches. Anything faster than light, or ubiquitous and interconnected like particles, would be a potential source of developing deep spacecrafts, more advanced spacecrafts, and propulsions. The untapped, unseen reserves of energetic particles. In conclusion, and this isn't even touching on other parts of the spacecraft, of course, or the design. This is just talking about methods of propulsion. But in conclusion, fast travel through the cosmos will be achieved. Also, through flights of imagination and pushing the envelope of known physics. And it's important to remember that can't and never won't lead to the groundbreaking innovation and incredible discoveries, unless it's used as an antagonizer, right? But otherwise, can't and never, you know what I mean, hopefully, won't lead to the groundbreaking innovation, incredible discoveries that we need and that are waiting for us. And as always, here's another favorite quotation. As always, somewhere, something incredible is waiting to be known. Carl Sagan, of course. That concludes Space Plus Technology, Advanced Propulsion for Interstellar Travel. And once again, this has been an overview for the purpose of inspiration, sparking ideas, and further study. For more information on Studio Shangri-La, please visit the website www.studio-shangri-la.com, and the podcast homepage has a lot of other episodes at this point, establishing the identity of the podcast and some of the tone. However, the podcast is definitely open to future guests, and looking forward to the variety that brings. Thanks for listening.